So this is the Unit 4 seminar, our Part 1, our Introduction to Trigonometry. And I'm just showing you basically for the first slide how the unit circle and actually dividing the unit circle into different trigonometric triangles is used to derive the cosine and sine curve. Now I have another unit circle in another slide, so maybe I'm going to get you to copy down that for your notes. I just wanted to explain that, so the x-coordinates of all the points on the unit circle are used to derive the cosine curve, and the y-coordinates of all the points on the unit circle are used to derive the sine curve. Now, the 30-degree triangle is a special triangle, 45-degree, 60-degree are all special triangles that can be flipped in the other quadrants to form the 120-degree, 135-degree, 150-degree triangles, and these are all based on special triangles, the unit circle. But let me give you a more clear diagram. So this is a little bit better because I've split it up into degrees and the corresponding radians, points that you're going to remember, and I really suggest memorizing. You have to know off the top of the bat for the next 3 units that 30 degrees is equivalent, 30 degrees is equivalent to pi over 6, that 60 degrees is equivalent to pi over 3, 90 degrees is equal to pi over 2. And later on in the seminar, I'm going to show you how we get those radian amounts. Anything with pi in it is equivalent to the radian measure, and we're going to learn how to convert from degrees to radians and radians to degrees. So all those degrees have an equivalent radian measure, and we usually express in the rest of the units all your degrees in terms of radians. Now, you'll notice from this diagram over here, all the special triangles built together turn into, help us plot the points of the sine and cosine curve. But like maybe in higher level mathematics, you'll actually be able to use triangles and you'll be responsible to construct the whole unit circle and kind of prove the unit circle, but not in grade 12 mathematics. Now, for the rest of the unit, we're not only going to be worried about, in grade 11 we really focused on the first quadrant. Remember, the top right is the first quadrant, top left is second quadrant, third quadrant, fourth quadrant. Now, when you are drawing your special triangles, remember that your base, so if I get my highlighter, your base is always along the x-axis. So we would never draw a triangle with a degree measure like that. That never ever happens. Your axis always, your triangles always have to be along the x-axis. That's why when you draw your triangles, it always looks like one part of the bow tie. We connect all these triangles in the different quadrants together, and they form sort of a bow tie. So always look out for that. Make sure your axis, your triangle, is always, the base is along the x-axis. Now, another thing you guys already know about the different quadrants, the cast rule. So if I write C-A-S-T, what does the cast rule stand for? Can someone tell me? What does the cast rule stand for? It deals with positive trigonometric ratios. All the trigonometric ratios are positive. That's why we start off learning trigonometry in the first quadrant. Over here, only cosine is positive. Only here, sine is positive. And here, only tan is positive. That means when you are given a positive trigonometric ratio, for example, cosine is positive, then you know you're only focusing on triangles and angles in quadrant 1 and 4. If you are told sine is negative, then you're only focusing on quadrant 3 and 4, because those are the only quadrants where sine would be negative. sign is positive in 1 and positive in 2. So you have to think in terms of all 4 quadrants, and you have to think where is it positive, where is it negative, not just in the first quadrant. You have to look at everything as a whole. Let me just calibrate the smartboard again, and we're going to do actually examples of drawing related triangles. Before we get to that, there's a few terms that you have to know. So obviously this is the cosine curve, and all our coordinates are used to form that. The sine curve with the degree measures and the radian measures for one cycle from 0 to 2 pi. Now, when we're talking about actually drawing our triangles, our bow tie triangles in different quadrants, you have to know the difference. You're going to be asked for the principal angle and the related acute angle. Now, whenever you draw something, like a line from the origin to a point, so for example, if you were given point 3, negative 3, positive 4. If you're given point negative 3, positive 4, you know that your x value, you have to go negative 3 units, and you would have to go up positive 4 units. From the origin to that point that you're drawing, that is called the terminal arm. And the terminal arm is usually the hypotenuse of the triangle that you're about to form. And the term terminal arm shows up in the definition. Now please copy down the definitions as part of your notes. Now, from the original point 0 to the terminal arm, that is called the principal angle. So this theta would be your principal, because we're going in a counterclockwise direction. This is the principal angle. And the related acute angle. The related acute angle is measured from the x-axis forward or backward to the terminal arm. So just going from 0 degrees on a counterclockwise direction is your principal angle, and backwards now would be your related acute angle. So whenever they ask you to solve for theta, you're also going to be asked to solve for the related acute angle as well. Now, last year, or also in grade 10, when you learned trigonometry, you were always talking about opposite, adjacent, hypotenuse, that sort of thing. But now, because we are looking at triangles in terms of x, y coordinates, your hypotenuse is also your radius, or your terminal arm measure. We have to look at sine, cosine, tan a little bit differently. Okay, so your sine function, which is opposite over hypotenuse, is also going to be represented as y over r. Your cos function, so the y coordinate over your r coordinate, your cos function is going to be x over r, opposite over adjacent over hypotenuse, and your tan function, opposite over adjacent, is y over x. Now, in order to find your radius, we usually use Pythagorean theorem, c squared is equal to a squared plus b squared, but we're talking about x and y coordinates. To simplify that, the radius is always the square root of x squared plus y squared. And that's just basic formulas that you can derive from the bow tie triangles that we're going to be forming. Okay, does everyone have this information? Can I move on to the next slide? Yes. Special triangles are key. You have to have memorized the special triangles just like last year. And because the special triangles are related to our radian measures that we're going to be using in order to come up with principal angles and related acute angles.